Hi guys, this video covers question number 10 of the first paper of 2015. This is a maximize minimize question. You will get one of these types of questions in your final exam, so be prepared for these. While people don't like them, they're not difficult questions as a whole. So question number 10 starts with, it says a rain gauge is the shape of a cone. Water flows into the gauge and the height of the water is h centimeters when the radius is r. So you can clearly see that as the water increases, the height of the water increases, this cone is going to get wider and wider. So obviously the height of the water and the radius are dependent on each other. It says the angle between the cone and the edge, the cone edge and the radius is 60 degrees as shown in this thing here. So you can already see what type of question they're going to ask. They're going to ask you to relate something to something else. In this case, they say determine r in terms of h and leave your answer in third form, and then they say maximize it. So they say determine the derivative. Well, they don't even tell you to maximize. They just say determine the derivative, which is even easier. But let's just redraw that so that we can work with it. So question number 10, they have a cone. Well, mine's not drawn as nice as theirs, but they've got some height h. They're saying that this, obviously this guy here is the radius r, and they're saying that this angle here, call that theta, is equal to 60 degrees. Oh, sorry, wrong angle. Looking at it again, it's this angle theta is equal to 60 degrees. Right, now they've given us all the formula we need, but the first question says determine r in terms of h. So r in terms of h, and how you interpret that is this is the subject of the formula. They're saying determine a formula that gives us r but is represented in terms of h. So we look and we say, okay, we're looking at volume, right? And it says formula for volume. They've given us all the formula for volume. Now how the hell do we choose which formula to use? Well, do we even use these formulas? No, because all they want is r in terms of h. And looking at this, we can see that we've got a trigonometric triangle. So we can determine r in terms of h here. So that is a 90-degree triangle. If you take it out separately, this is what we have. We've got this angle here, which is 60 degrees. That is r, and that is h. So what do we need? Here, that's our opposite. That's our adjacent. So what we say is tan of theta, which is 60 degrees, is equal to the opposite side, h, divided by the adjacent side, which is r. And they want r as the subject to the formula, so we simply multiply everything by r, and we get r times tan of 60 equals h, and then divide everything by tan, and we get r equals h divided by tan of 60 degrees. And that's very important because now we have the radius in terms of the height. So now if we want to find out the radius, all we need is the height. So the actual radius value doesn't particularly matter as long as we have the height, because then we can find the radius. So that is 10.1. Let's just make that 10.1. 10.2 says determine the derivative of the volume of water with respect to h when h is equal to 9 centimeters. Blah, blah, blah. That's weird. What do we have to do? 9.2. It says take the derivative of the volume. So what is the volume? How do we figure out volume? Well, you first got to remember what the hell the volume of a cone is. The good thing is there are 4 formulas. If we look at these 4 formulas, we have this guy, which is pi r squared times h, But pi r squared times h is the area of a cylinder right? Or the area over here, that's this area, multiplied by the height h to get the volume of a cylinder. Length times breadth times height you should recognize as a rectangular box. Length times breadth times height, you should recognize that. And then this one with a cubed is the volume. No, I can't draw that. Maybe I can. That is the volume of a sphere. So you should know which one's which. That is very important. That leaves us with this guy as the volume of a cone. Okay, I'm not sure how you want to go about doing that or remembering that, but you need to know what the volume of each thing represents. So that's the only one that works, so that's the one we're going to choose. Okay, so for 9.3, what they're looking for is they're saying, well, find the volume of the cone, and when we look at the volume of the cone, we know that it's 1 over 3 pi r squared times h. And just to note, if you have a sphere is a 3D circle. So you have a circle in 3 dimensions. So you're going to have an r cubed with a sphere. A cone is a circle in 2 dimensions with some height, which is going to be 2 dimensions, so r squared. I don't know if that helps you remember it, but nonetheless, that's how I like to remember it. Okay, so we want to find the derivative of the cone with respect to h, but in order to do that, we need to get this whole thing with respect to h. And the good thing is, we have r in terms of h. Pi r, which is up here, we see it's h divided by tan of 60, and square that times that by h. So we square that and we end up with 1 over 3 pi times h squared over tan squared 60 times h, and we simplify that further and we see it's 1 over 3 pi times h cubed over tan squared of 60. Now I'm going to simplify that one step further, and I'm going to take out all the numbers and just leave the variable h. So we get pi over 3 tan squared 60 multiplied by h cubed. Now we can take the derivative of the cone with respect to h, and we see that, well, that's actually quite simple, because it works out to pi over 3 tan squared of 60 times by 3h squared. The 3's cancel, and we're left with pi h squared divided by tan squared of 60. And one thing you must remember is tan squared of 60 is just a number. And they're specifically saying at a height of 9 centimeters. If you remember the question, it says determine the derivative of the volume with respect to h when h is equal to 9 centimeters. So we have 9 centimeters. So that means we literally find the volume when, or the derivative of the volume, when h is 9 squared divided by tan squared of 60. And what does that actually give us? Well, that gives us the rate of change of volume. And we can see that works out to 84.82 in this case centimeters squared per cent, or centimeters cubed per centimeter, so centimeters squared. Okay, and that's it really. I can't think of anything else to add to this. The one thing I just want to mention is when you are doing a question like this, now this one they specifically told you to take the derivative, but whenever you get a question like this, what you need to realize is you get an equation and you derive it. They're going to ask you to either maximize or minimize. Regardless of whether it's a maximize or a minimize, you take the derivative of that equation.